A very good day, my dear postgraduate students. I shall be continuing with my classes on bone marrow aspiration. And today's class is identifying some cells such as the myeloblast, the lymphoblast, and the promyelocyte. Thanks to this particular reference, they have compiled a beautiful picture of the myeloblast, which is a large cell which has got a round contour, and it has got actually an abundant cytoplasm which is being replaced by a large nucleus, such that there is a large nuclear cytoplasmic ratio. There are some prominent bubbles which I can see in the nucleus, which is the nucleolus. So the nucleolus in this case are about 2 to 5 in number. The cytoplasm does not have condensed chromatin. It is fairly opened up, and there are no granules in the cytoplasm. The nucleus has got an open chromatin. Nuclear cytoplasmic ratio is increased. Now, it will be our responsibility to identify such cells in the bone marrow. And here again, this is a cartoon picture of it. I find that the nucleus is not round, it is not irregular, but slightly convoluted, which is a characteristic of a myeloblast. And these pale areas are the nucleoli, which are about 2 to 5 in number. The cytoplasm is again seen over here. In this one, the yellow mark points out to the myeloblast. See these pale areas, and they do not have an outline as such. They are the nucleoli. The chromatin is fairly opened out, and the cytoplasm is there. No granules. So I would like you people to kindly identify the blast. I'm not going into the diagnosis, only the identification of the cell. In this case, we should have a doubt. What other cell can it be confused with? One can be a proerythroblast. Proerythroblast is a precursor of a basophilic erythroblast, after which you have the other cells. That is one. Two can be a lymphoblast. This is extremely important for us in making a diagnosis in the leukemia. So this is the myeloblast. So these are the features of the myeloblast. It is about 3 to 4 times larger than the RBC. High NC ratio, therefore very little cytoplasm. Round nucleus with immature chromatin. Sometimes you find that the nucleus will be convoluted. That is more important. Prominent nucleoli, cytoplasm is scanned, gray to pale blue. So this is an important feature of it. And it lacks granules. The normal percentage, the peripheral blood, the bone marrow, and the lymphoid tissue should be known. In the peripheral blood, you do not find any blast normally. Bone marrow, it is scattered about 1 to 3%. And in the lymph node, we do not see the myeloblast. It can resemble other cells such as the promyelocyte, pronormoblast, immature B cell, lymphoblast, monoblast, and the reactive lymphocyte. These are certain things which we should have in mind, and let us see how well we can demarcate them from this. Look at this again. So it is a little hazy, not very darkly stained. I am finding a large round cell. There is an area of haziness over here, which is the nucleolus. The other cells do not have such features. They are much smaller. So now I hope you people are able to appreciate about 2 to 3 nucleoli. Over here, the chromatin is slightly opened up. At the same time, the cytoplasm has got some granules of it. So it is the next stage of a myeloblast. That is the promyelocyte. In fact, the promyelocyte is the larger cell than the myeloblast. So what are the features we shall be seeing subsequently? Look at this. Large cells. I hope you people are able to see some nucleoli, which are not very distinct, but characteristic will be the granules. These are called the primary granules or the azurophilic granules. The nucleus is slightly eccentric, and please do appreciate that the nucleus is also slightly convoluted. There is an indentation, but otherwise it is more or less oval or so. This can be a myelocyte in which I am finding some granules which are secondary granules, but then the nucleoli are not very prominent. In the background, of course, I am finding uniform small cells. They are the red cell precursors. Identify a cell by the company it keeps. So, this is the largest of the myeloid series. It is larger than the myeloblast. Primary azurophilic granules, 2 to 3 or even 5 nucleoli. Eccentric, convoluted. And there is a kind of a region, something that you see in a plasma cell. There is a hole or a clear zone that is surrounding the nucleus. This is again a picture of a promyelocytic leukemia, but there are two things we'll have to appreciate in this picture. One, I find that there are coarse granules and the nucleoli. I hope you people can make out because it is a little darkly stained. This is the promyelocyte over here. But again, these cells are all extremely large and bizarre. And in the cytoplasm, I am finding multiple rod-like structures. We may call them a bundle or a stack of it or fagots. That is the name that we give to it. So here again, I am able to make out some nucleoli, granules are present. The only cell that has got both the nucleolus as well as the granule is the promyelocyte. So it is one stage of a leukemia. I shall not be going into it right. So this is again a cell that is smaller than the promyelocyte. It is again about 3 times larger than the RBC. Cytoplasm has got granules. Nucleus does not show any nucleoli. There is a condensation of the chromatin. It is eccentric, coarse chromatin, no nucleoli, and secondary granules according to the nature of the cell. It can be eosinophilic, basophilic, or neutrophilic myelocyte. What do I see in this picture? Obviously, I am not able to see the normal cells at all. Most of them are large and they have got a round or oval nucleus. There is an indentation, prominent nucleolus in some. So look at the dip over here. There is an indentation that I can make out. Some of the cells have got some convolution. So this is one. It can be looking like a monocyte or looking like a blast to me. So they are large, round, reniform, and the indented nucleus. It is there. Nucleoli 1 to 2. And look at this one. This is again a counterpart of it. I find that there is a vacuolated cytoplasm that we find in one of the types of leukemia, namely the monocytic leukemia. Lymphopoiesis is something that we should study because it can be confused with the myeloblast. So there is a hemocytoblast. It matures into the lymphoid series. There is a common lymphoid precursor. And just like a myeloblast, I get a lymphoblast over here, large round cell. The chromatin is more condensed. Nucleoli are less in number, 0 to 1 or at the most 2 in number. And it becomes a pro-lymphocyte, and it can be either an NK cell or a small cell from which you can get the B lymphocyte, ultimately the plasma cell. This will be the lymphopoiesis. Do not get confused with the types of leukemias, etc. The purpose is mainly to appreciate the difference between a myeloblast and a lymphoblast. So look at the lymphoblast over here. Here the chromatin is more condensed. Again, I am finding 1 to 2 nucleolus. The cytoplasm is more basophilic and the chromatin is condensed. Size will be about 15 microns, whereas the myeloblast can be up to 20 microns. Again, it's a large cell, slightly eccentric nucleus, and there are no granules. Now, what are basically the differences between the myeloblast and the lymphoblast? This you people shall by heart. So, precursor of myelocytes, lymphoid cells. 20 microns, 15 microns. May contain myeloblast. There is a granular variant, but usually no granules. Here also there are no granules. Nucleus round to oval or convoluted. Here it is round. The chromatin less condensed. Here it is more condensed. Fine nuclear membrane. Here there can be a more dense nuclear membrane that I see. And the cytoplasm is scanty. R.A.T.S can be seen. Here it is scant, blue and A granule. It can develop into various cells, the myeloblasts such as the eosinophilic, neutrophilic or a basophilic series. Here the T and the B lymphocytes. The leukemic counterpart is the AML. Here it is the AL. Kindly by heart this and keep it in one corner. Incidentally, this is the type of leukemia. The RBCs are normal, normocytic, normochromic. Some schistocytes are there, fine. Platelets are reduced. And there are abnormal cells varying in size. This is a small cell and I'm seeing two larges. A mixture of the small and the large cell, which is typical L2. So it is a lymphoblastic leukemia that I'm seeing. Here again, I'm finding some cells which are having vacuolated cytoplasm, but some again eccentric nucleus. There are some R.A.T.S which I can make out. So clear. So let me see in the larger magnification. I'm able to see the R.A.T.S in this. There are the prominent nucleoli. Convolution is. So it is a myeloid one. Some of the cells have got a vacuolated cytoplasm that I can see. Again, platelets are reduced. So this can be a leukemia, myeloid leukemia, definitely because I'm seeing the R.A.T.S. Sometimes there is a confusion between it. Therefore, we'll do a flow cytometry or a cytochemistry. But otherwise, my diagnosis will be somewhere between M2 and M4. If it is purely monocytoid, then it comes under M5. So thanks to this wonderful reference for the picture, again see the nature of the myeloblast. And this is incidentally a picture that is picked up from the Atlas of Histology. I find these are all called as rubicites or the red cells. So they are getting matured into the orthochromatic cell. This is the polychromatic cell that I am seeing. Okay, prorubicin. This is incidentally, I am putting this picture purposely so that it is a recapitulation of our original classes. But one thing, in one field, I am seeing all the cells over here, which means identify a cell by the company it keeps. To be continued. Thank you.